Here's my hack in how to solve questions as regard to resolution of vectors for coplanar force, right? I have my own hack. There's an easier method we use to solve questions as regard to this. So step one, there are three basic steps we are going to apply. Step one, we resolve all the forces into their x and y coordinates, right? So what we do is to take the sum of all the force in their x and y coordinates. So summation of the force to the x-axis, this means sigma, right? This means sigma. Summation is the symbol for summation of x or the x-axis. Since we are resolving to the x-axis, we're going to multiply the force times its angle, right? So the first one, this F1 now is going to be this, is going to take this angle. This is for the first one, so let's call it theta 1. Let's call this theta 1. So it's going to be F1, right? F1 theta cos theta 1, right? Because we are resolving to the x-axis, right? So we get to the F2, we resolve from this axis, from this this static axis to this part, right? So let's call this our theta 2. So it's going to be F2 cos theta 2 plus F2 cos theta 2 plus, now we're getting to this F3, third force. So we'll start from here and resolve down. So it's going to be F3 cos theta 3. It's just going to be F3 cos theta 3 plus F4. For F4, we start from here again and resolve till we get to our F4. Right? So it's going to be F4 cos theta 4. Starting from here, we're going to have F4 cos theta 4. Right, as well as F5. So we start from here again 0 and then we count till we get to F5. So it's going to be F5 cos theta 5. So let's just add it here plus F5 cos theta 5. Right, so we sum up this force, we resolve all this force, so it's S comes to the S component, right? Doing that we get an answer. Having done that, we resolve all forces again the Y axis, right? So in doing that, here's what we do. Because we have taken the time and liberty to get all the individual forces for the F coordinate, what we do for the Y coordinate is going to be F1. We just change this cos to sine. So instead of cos theta 1, just going to be sine theta 1 plus F2 sine theta 2 plus F3 sine theta 3 plus what? F4 sine theta 4 and then plus what? F5 sine theta 5. Whatever we get there, we resolve them to their x and y coordinates, right? X and y components. So having gotten the answer, we're going to have just two components, right? Two coordinates. So this is the s coordinate, summation of f of x, whatever we get for the x-axis, whatever we get here, we fix it here, right? And this is for the y coordinate, whatever we get for the y, this one is for the summation of what? Of y, the force for the summation of y. Having done that, replace that, we'll get the resultant force, right? I told you guys on how to get the resultant force. It's by taking this part, they're the same thing. What we get here, so we're still going to apply here, so that we can form the triangle of forces. Here becomes f summation of fy, the same thing. And so in getting the resultant force, r square, we apply what we call the Pythagoras theorem, right? Square of the hypotenuse r is equal to the what? The sum of the squares of the opposite and adjacent. Let's assume we are finding a distance here. So with that, we're going to have, and these are opposite, right? Forming an angle 90, these are opposite. So we have EF of y or square plus what? EF of x. A summation the force of x or square. Having done that, our arrow is going to be the square root of everything here, right? EF of y or square plus what? EF of x or square. And that's how to get the resultant force, right? This one is how to get to resolve all the force into their x and y coordinates. Having done that, we're going to get the resultant force, and this is the formula for the resultant force. sometimes it might ask us to find the magnitude and what and direction. So how do we get the direction? Direction, which is on this plane, is going to be tan theta, which is equal to opposite of adjacent. That's EF of y over EF of x. Having gotten this, our theta is going to be shift of tan, right? Inverse of tan of what? EF of y over EF of x. So this is all we're going to be doing to get the value of our x and y coordinates, right? So in our next video, I'm going to give you a typical questions, right? I'm going to give you a typical question on how to find the magnitude and the direction of forces on coplanar axis. I'll see you in the next video, guys. Thank you. Alright guys, question 1 question says we should find the value of the magnitude and direction of the coplanar forces in the diagram above, right? So that's the diagram above. They're all coplanar forces. They are acting at a point, right? So how do we solve this? Very simple. I'm going to be using my own method to show you how it works. So here's how it works, guys. I said we're resolving the force into two axes, right? Both the x and y axis. So summation, the f of x is going to be f1 cos theta 1 plus f2 cos theta 2 plus f3 cos theta 3 plus what? f4 cos theta 4 plus f5 cos theta 5 plus f6 cos theta 6 plus so on and so on with fn cos theta n. Alright, so that's how it works. So let's start replacing that. So EF of x. Now watch what I'm going to do. The first force is this. This is our first force because it's going like this, right? It's going like this. So there's no force here. This is our first force. So from 0, we counted, discovered that this part is 630, right? So the angle here, this our theta 1 is at 30 degrees. So the first force is 50. That's our F1 is 50, which will be 50 cos, well, what's our theta there? 30, because it's from 0 down to 30. We are counting for all forces. We'll be starting from here as our reference point. Alright, so it's 0 to 30. So F1 cos 30. That's the first one. What's our F2? This is our F2. So we'll be starting from here. This will be 0, right? 0 to 90. Because if you watch, if this part is a 90 degree part, so if this is 30, this part will be 60. So counting from here to be 0 to 90. So we have F2, which is 20 cos 90 plus what? Remember, it's degrees, right? Plus what are F3? These are F3, right? So this will be 0 going to 90. So we need this part of the board, this part, this angle, because we already have 90. So what's this remaining point? If here is 60, here should be 30, right? Because if you watch, this is a right angle triangle. So if this part is 60, if from here to here is 60, it means from here this part is 30. So looking at this from 0 to 90, 90 plus 30 gives us 120. So it's going to be what? From here down to here is going to be 120, right? 60 cos 120 because we're starting from here. Reading down 90, adding to this 30 that is here because this part is 60, giving us 60. So we have here as 30. That should be what? 120. So we have 60, so our F3 cos what? 120 degrees. What's our F4? These are F4, right? So I'm going to start from here. Remember, if we move from here down, we already have 180 angle on a straight line, right? So what do we need to get to this point, right? If here is 60, here is 30. So 180 plus 30, that's 210. So look at it, 180, 190, 200, 210. So from here down to this part is 210. So we have 10 cos 210, so F4. This is 10 cos 210 degrees. What are F5? These are F5. So from here, if we count down 180 and we're coming here, it means we are here, we're stopping here at 270, right? 90 plus 90 plus 90, that's 270. So we have 6 cos 270. So this is 6 cos what? 270 degrees. Plus what else? We still have this one. So if we count here, from here down 90, 90, 180, 270, we need this part, right? But we already have here as 13. So here will be 60, right? This part will be 60. So 270 plus 60, that's 330, right? So we're going to have 24 F6 as 24 cos 330. right? So let's try and add this first. Let's see what we get. So our EF of X is going to be 50 cos 30. You're going to give us what? Here on my calculator. So let's do 50 cos 30. We have 43.30. That gives us 43.30 newtons, please. Right? 3.30 newtons. Or we'll just add the newtons at the end. Let's just get the values. Plus 20 cos 90. 20 cos 90. What do we have? That's 0. So if we multiply everything here, we're going to get 0. Plus 60 cos 120. What do we have? 60 cos 120. What do we have? We're going to have minus 30. So with that we have minus 30. Plus 10 cos 210. 10 cos 210. What do we have? We have minus 8. Oh god, there's minus 8.660. Right? Yeah. And then let's try 6 cos 270. Use your calculator, please. 6 cos 270. What do we have? We got 0. So with this we have 0. Plus 24 cos 330. What do we have? We got 20.79. Sorry, 78. Yes, 20.78. Sorry. All in newtons, please. All of them are in newtons, please. Right? See how easy it is. So let's add. So our summation of X gives us what? So let's add 43.30 plus or minus 10 plus 0 minus 30 minus 8.660, right, plus 0 plus 20.78. What do we have? We had do everything here, sum everything. We have 25.42 newton. That's our summation of X. We got there. So let's get the one for Y. So by doing that, EF of Y. Now Y becomes simple. What do we do with Y? Just fix in the value, but change all our costs to sign. That's how easy again. So by doing that, we're going to have, hold on, Christian. How many minutes more? 6 minutes. We're going to have 50 sine 30 plus 20 sine 90 plus 60 sine 120 plus 10 sine 210 plus 6 sine 270 plus 24 sine 330. Alright, so just give me a moment. I'll add all of this to save space in the video. I'll add all of this and then give you the final answer while you do that with your calculator. Alright guys, so I haven't done that with my calculator. 50 sine 30 gave us 25, 20 sine 90 gave us 20, 60 times sine 120 gave us 51.96, 10 sine 210 gave us minus 5, 6 times 270 gave us minus 6, and then 24 sine 330 gave us minus 12. Alright, so we're going to add everything, take the sum of everything. EF of Y gives us what? So let's try. 25 plus 20 plus 51.96 minus 5 minus 6, and then what? Minus 12 give us what? For Y give us 73.96. Alright, yep, so we'll add all of them. We got 73.96 here. You can try yours. 25. Alright, so all in newtons, please. So now we've gotten the value for EF of X and EF of Y. So let's just put it here that our EF of Y gave us 73.96 newton. Alright, so by resolving these forces, right? So let me clean this part of the board so that I can use this part to do the resolution of the force and then find our resultant vector as well as our direction to see how it works. Alright guys, so let's resolve the forces, right, into their X and Y components. So for the X axis, our EF of X gave us what? Gave us 25.42 newton, and that for Y, EF of Y gave us what? 73.30 0.96. Our job is to find the resultant, right? And to give us the same effect of all of that force. So F resultant. Our resultant force, we know our resultant force is going to be the square root, right, of EF of Y all square plus what? EF of X all square. So what do we do? Our resultant force becomes what? That gives us for Y, we have 73.96 all square plus what? 25.42. 5.42 all square. So let's do that in a jiffy. Take the square root of 73.96 all square plus 25.42 all square. By doing that, our resultant force, we got 78.20 Newton. That's the resultant force. Alright, so what about the direction, right? We said direction, which is our theta, that's the one for theta here, is going to be what? Tan of what? EF of Y over EF of X. We'll do that. What do we have? At the tan of that, shift tan, that is the inverse tan of EF of Y should be what? 73.96 over of X should be what? 25.42. 25.42. So we do that with our calculator. Our theta becomes what? That's theta. It's theta, please. That becomes what? You go to your calculator and then you press the shift button and then you press the tan, right? And then if you are using my calculator, you can press the button or below the calc button there. So we have 73.96 all over 25.42. Sorry, not 42, please. 42. Right. By doing that, we have 71.03 degrees. Approximately 71 degrees. That's your answer. Right. So we've gotten the magnitude, which is the resultant force. Right. We've gotten the magnitude and the direction. The magnitude there gave us 78.20, and then the direction gave us what? Theta gave us 71 degrees. It's very simple. Just by looking at the values, see how it works. They're very simple, right? I just want you to know how my idea as to how to solve or resolve coplanar force. So we'll take another example, two or three other examples. We'll buttress on them so that we can master the act of how they work. I'll see you in the next video, guys. Thank you.